hash include iostream using namespace std, and I'm just going to copy these headers from here. All right, so we have a class circle, and we have a private int r const float pi equal 3.14, and we have public functions. We have a public constructor circle int r. This r equals to r, this would remain the same, and we have a draw function void draw. This would remain the same as well. Cout circle and l, and area function float area, return pi into r pi r squared. So as we talked before, we noticed that these classes are related in a way, and each of them has a common void draw and float area function, that is rq for using inheritance. So we are now going to make a general parent class, and these classes of shapes will be their child classes. So let's make a parent class shape. So it would have pure virtual functions of void draw and float area. So public. So now we will make our virtual functions that will be using abstraction. These are called pure virtual functions. Virtual void draw equals 0 and virtual float area equals 0. So what is happening here is that the implementation details of these functions is being hidden. The class that will inherit shape class will define these functions in their respective classes. So to other programmer that is just looking at shape class, or if we give the shape code to the programmer, he won't be able to see the implementation details of these two functions. And that is what is meant by abstraction. That is a good programming practice, that you only show to others what you want to show them. You don't show them excessive details that is not needed by them. So that will be our shape class. Also, there's something else I wanna tell here. If our class has at least one pure virtual function, function is a pure virtual function if it has an equal to 0 sign with a semicolon and it is undefined. So if a class has at least one pure virtual function, then it is called a pure virtual class. So here shape is our pure virtual class. So now we need to use inheritance class circle public shape. I hope I'm using the right syntax. Yeah, it should be a colon here. I think now it's okay. I think now it's yeah. So the formatting is disturbing me a bit. Alright, so this seems good. So now we have a shape class and we have a circle class. Now we will make other classes, and we have a rectangle class rect public shape, and we have a private member int length int width, and we have a public member and we have public functions rectangle. Let's just go ahead and copy this here. Public, right, so format selection. All right, so next we have class triangle. Let's just go ahead and copy this here as well, and just add the public shape. Now we have a class figure. Now you will see how easy it gets here to introduce a new class if we have to introduce them. And you will see how using inheritance and polymorphism abstraction, our code is simplified. This code will be simplified. So let's take a look. Class figure. Now instead of having a list for each of these classes, we will just have a common linked list of shape class. Using just one linked list, we will be able to make use of each of these classes through polymorphism. List shape star is shape, right? And now we have our public functions. We have an add function. We will be just adding the shape pointer to the shape class. Void add shape star s, and we have is shape dot pushback and s. So you see how using these principles we have simplified our work. Now we don't have to make 3 functions for each of these classes. We can just make it using a shape class. Similarly, now we will make void display and float sum functions. Void display. Okay, I'm just going to copy the syntax here. Shape star iterator it1, right? And now let's make the loop for it1 equals is shape dot begin. For it1 equals is shape begin, it1 is not equal to is shape dot end n plus plus it1. So basically the iterator just goes through the linked list. This for loop means go through the linked list from start value to the end value one by one. So we will go through each element of our shapes one by one, and we just want to display them, that what shape we have, like we did here, circle, rectangle and a triangle. So this function is doing that, and that is the syntax here. So if you don't know how to use iterators or linked list, just know that I'm basically trying to access the elements of a linked list like we do in an array using for loop. That is what is happening here. Okay, so I don't have to make these 3 lines of for loops. All the work is simplified using one for loop. And the advantage here is that when we add new classes, when we add a new oval or a polygon, any other class, we just have to write the code for the class like we have written here for class triangle. We would just introduce the class and its data types and its functions. We would not have to change the figure class. The figure class would remain as it is. That is the beauty of using polymorphism. Similarly, we have a float sum function. Float sum, float total is equal to 0, and we would just want to make one loop here. List shape iterator it for it is equal to is shape dot begin. It is not equal to is shape dot end plus plus it. Now we would add the sum of the area to our total variable. Total plus equal to it area, sorry. And now we will return our total. Alright, so our work here is almost done, I think. Yeah, now we just want to make the main function. The main function will remain as it is. So you can see how we have simplified our work and why is this a good programming practice. So, okay, I'm just going to copy paste. No need to write it down again and again. Alright, so now we will format our code. Okay, format selection. Alright, so there we go. Let's try to run this code. G++, good code. Right, there is an error here. I'm not sure why though. It says an undefined reference to main. Okay, what's that supposed to mean? Let's just Yeah, I think I'm probably missing a semicolon somewhere. Oh, right. I never finished this class. Okay, so that is the thing. Oh, yeah, the main is inside Refactor class. So that is the error. Alright, so there we go. Format selection. Alright, this should work now. Okay, all good now. Let's uncomment these functions. Alright, let's print out. Good, this is working. So we will so we saw that how using object oriented practices will simplify our code, and now it's incredibly easy to make changes to the code and add new classes to the code. This is essential when we are working in too many classes and each of these classes is interacting with another class or another class's function. So in such scenarios, if you are not using the object oriented practices, if you are just doing the work manually works as well, but it is only good if the code is small, if you are using minimal number of classes. But in professional settings, you don't use minimal number of classes. There you are assigned big projects and there are plenty of classes, there are plenty of functions. In such scenarios, it is essential to use these principles.